of this potential of sogenannte tape verpack article process verwendet. Chromium Electroplating.
Dimensions check out on the SMC batch.
All right, visually approved. Let's get these moved inside.
Wait, this beam is damaged. Tag it for return.
Proper racking ensures electrical contact, allows drainage, and positions parts for uniform chrome coverage. Contact points are placed in non-critical areas.
The first cleaning step removes oils, greases, and organic contaminants using hot alkaline solution. This step
Vigorous hydrogen bubbling indicates active cleaning. The steel surface turns uniform matte gray when complete. Another thorough cold water rinse follows acid cleaning. pH testing ensures rinse water is neutral before parts proceed. A quick acid dip activates the surface for immediate plating. Parts immerse in dilute sulfuric acid for just 5 to 30 seconds. For decorative chrome, a nickel undercoat is essential. The thin chrome layer is porous, so nickel underneath provides actual corrosion protection and brightness.
Semi-bright nickel plating deposits the first 15 to 25 micrometers of undercoat. The solution contains nickel sulfate.
Parts rinse in cold water after semi-bright nickel to remove all solution before entering bright nickel. 2 rinse tanks in series ensure no contamination between nickel baths. Another thorough rinse removes bright nickel solution before chrome plating. At least 2 cold water rinse tanks with high purity.
Chrome plating operates at 45 to 55 Celsius applications and 50 to 60 Celsius for hard chrome.
Parts transfer from activation directly into the chrome bath within seconds. Current applies immediately upon immersion. Vigorous hydrogen gas evolution covers all surfaces.
Chrome bath maintenance requires weekly chemical analysis. Chromic acid concentration, sulfate level, and their ratio must stay within tight ranges.
Immediate cold water rinsing after chrome removes toxic chromic acid from part surfaces. Multiple rinse tanks with counterflow operation minimize water use and chromium discharge.
Some operations add a hot water rinse at 60 to 80 degrees after cold rinsing. Hot water accelerates
Final rinse after passivation uses high-purity deionized water with TDS below 50 ppm. This prevents water spots and mineral staining on the finished chrome.
Forced hot air ovens dry parts at 60 to 90 degrees Celsius for 5 to 15 minutes. Proper drying prevents water spots and
The probe is placed on the surface, and the digital readout shows coating thickness. Gauges require regular calibration.
Adhesion testing verifies coating bond strength. The tape test applies pressure-sensitive tape firmly, then removes it rapidly to check for peeling. Systematic defect analysis identifies root causes when problems occur. Pitting indicates contamination or inadequate cleanings.
Hard chrome differs fundamentally from decorative chrome. Applied directly to steel without
hard chrome surface preparation requires aggressive cleaning and pickling, since chrome applies directly to steel.
Hard chrome deposits achieve 850-1000 HV hardness, significantly harder than tool steel.
After hard chrome plating, parts undergo grinding or polishing to final dimensions and surface finish. Cylindrical grinding reduces diameter precisely.
Hexavalent chromium is highly toxic and carcinogenic, requiring strict safety controls. OSHA limits airborne exposure to 5 micrograms per cubic meter.
Quality assurance requires systematic process control. Statistical process control tracks thickness,
Troubleshooting guides rapid problem resolution. Pitting requires carbon treatment and improved cleaning. Blistering indicates adhesion failure from contamination. Burning suggests excessive current density.
Chrome plating facilities require significant capital investment. Rubber or PVC-lined steel tanks hold 5.
Chemical management ensures safe handling. Add chromic acid flakes slowly to water, never reverse.
Preventive maintenance schedules daily checks, weekly inspections, and monthly servicing. Regular maintenance prevents costly. Direct costs include chromic acid at 50 to 150 grams per square meter. Nickel salts for undercoats. Decorative chrome is thin and bright, typically under a micrometer thick, used for appearance and corrosion protection. Hard chrome is Specialized applications have unique requirements. Aerospace hard chrome follows strict specifications like
regulatory compliance requires comprehensive programs. OSHA hexavalent chromium standard mandates exposure monitoring. ISO 9001 quality management systems establish documented procedures, process control, and continual improvement.
Ensure the safety interlocks are engaged before we start the sequence. This prevents exposure.
And the pressure settings?
Those are automated, but always double check the readout here.
Production control manages workflow efficiency. Planning balances customer orders with capacity. Work orders detail specifications and routing. Quality documentation certifies compliance. Technical support assists with application questions. Excellent service differentiates successful chrome plating businesses.
Local exhaust ventilation captures chromic acid mist at tank surfaces. Wet scrubbers neutralize acid fumes with alcohol.
Energy management reduces operating costs, improving insulation, heat recovery, and efficient equipment.
Water conservation minimizes resource use and wastewater volume. Counterflow rinsing reduces fresh water consumption.
Automation increases efficiency and consistency. Robotic part handling reduces labor and exposure. Automatic plating lines control immersion times precisely.
Examining the panel reveals problems like depleted additives causing dullness, excessive impurities causing roughness, or wrong chemistry causing burning.
Rectifier selection matches application requirements. Precise
stations. Rack design critically affects plating uniformity. Contact points must provide low resistance. Insulation directs.
Tank construction materials resist chemical attack. Steel shells provide strength. Rubber or PVC linings protect.
Filtration maintains solution cleanliness. Continuous circulation through cartridge filters removes particles and sludge. Anode configuration affects current distribution. Lead tin anodes resist chromic acid corrosion. Conforming shapes follow part geometry for uniform plating. Ventilation system design captures hazardous fumes. Slot hoods along tank edges provide capture velocity of 30 to 60 meters per minute. Temperature control maintains optimal plating conditions. Immersion heaters use titanium or quartz elements. Thermostats regulate within 2 degrees Celsius tolerance. Current density calculation determines amperage required. Formula: amperes, Imbus current density, Imbus part surface area. Decorative
plating time calculation determines immersion duration. Formula: time used tanks. Desired thickness Aus constant / current density Aus efficiency. Throwing power describes ability to plate recessed areas uniformly. Chrome has poor throwing power compared to other plating processes.
Brighteners and nickel baths create mirror finish. Brightener balance is critical. Depletion causes dullness, while excess causes stress and brittleness. Drag-out recovery reduces chemical loss and waste. Drain boards between tanks allow solution to drip back.
Surface finish requirements vary by application. Hydraulic cylinders need 0.05 to 0.5 Rive 1 micron.
concentrated hydrochloric acid at 30 to 37% dissolves chrome. Immersion for 15 to 60 minutes with hydrogens. Thickness specifications define required coating. Decorative chrome specifies 0.25 to 0.7.
Adhesion failures cause blistering or peeling. Root causes include inadequate surface preparation, contamination between layers, or insufficient activation. Pitting defects appear as small craters. Causes include organic contamination, metallic impurities, or hydrogen bubbles. Burning produces dark, rough deposits at high current density areas like edges. Current distribution optimization prevents burning. Non-uniform thickness results from poor current distribution. Inadequate anode configuration, electrical contact resistance.
Prevention requires deionized final rinse water with TDS below 50 ppm, prompt drying after rinsing, and proper drainage.
Article inspection validates new products or processes. Complete dimensional inspection, material verification, and process documentation prove capability.
Statistical process control monitors key characteristics over time. Control charts track thickness, appearance, or defects. Preventive maintenance schedules systematic equipment care. Daily checks verify operation. Weekly inspections catch developing.
Safety training protects workers from hazardous materials and processes. Hazard communication covers chemical dangers. PPE training ensures proper protection.
Environmental permits authorize facility operation. Air quality permits regulate emissions. Wastewater discharge permits control effluent. Waste minimization reduces environmental impact and costs. Process optimization cuts chemical consumption.
Personal protective equipment prevents chemical exposure. Nitrile gloves resist chromic acid.
Emergency response procedures address chemical incidents. Spill containment prevents spread. Neutralization reduces hazards.
Continuous improvement drives operational excellence. Problem-solving methods identify root causes. Supplier quality management extends standards upstream. Chemical supplier qualification ensures quality.
Capacity planning matches resources to demand. Tank utilization analysis identifies bottlenecks. Equipment.
Lean manufacturing eliminates waste and improves flow. Reducing setup times enables smaller batches.
Quality costs track prevention, appraisal, and failure expenses. Prevention costs include training and process control.
Customer specifications define exact requirements. Drawings show dimensions and tolerances. Process specifications detail.
Lot traceability tracks materials through processing. Unique batch numbers identify parts. Records link batches to process parameters and results.
Corrective action addresses identified problems. Root cause analysis determines why problems occurred. Corrective actions eliminate cause.
Management review evaluates quality system effectiveness. Periodic reviews examine metrics and trends.
Process validation demonstrates consistent conforming output. Installation qualification verifies equipment setup. Risk assessment identifies potential problem crumbs.
Benchmark comparison with industry best practices identifies improvement opportunities. Performance metrics compare to standards. Gap analysis reveals deficiencies.
Workforce engagement involves employees in improvement. Suggestion systems capture ideas. Problem-solving teams address issues.
Knowledge management captures organizational expertise. Standard operating procedures document best practices. Proactive succession planning prevents capability gaps from retirements or departures.
Technology adoption keeps operations current. Automated controls improve consistency. Advanced monitoring provides real-time data.
Customer relationship management builds loyalty.
Strong customer relationships create sustainable business through repeat orders and referrals.
Value-added services differentiate offerings. Engineering support assists part design for plating. Express service meets urgent needs.
Financial management ensures profitability. Cost accounting tracks expenses. Pricing strategies balance competitiveness with margins.
Strategic planning sets long-term direction. Vision and mission define purpose. Goals establish targets. Regulatory compliance protects license to operate. OSHA standards ensure worker safety. EPA regulations control environmental impacts.